In this video, I will go over the homework that follows the lecture 1.1 called Exponents, Exponential Functions, and their limits. And as always, I hope that you already watched all these lectures, as I will be making references to them, and I expect you to watch and somewhat understand the content presented in those lectures. So let's get started with the homework. And the homework is 1.1, so I can just load it in this screen right over here. And here's our first problem. So given the function f of x, we are asked to evaluate this function at 6. And in this regard, there is no much difference between exponential or any other functions. To evaluate the function means to find the output when the input is the set value. So in this case, we replace x with 6, and we carefully calculate the expression. So 24 times 27, we can grab a calculator here, or we can always just type this in any browser and it should compute it. So 24 times 27 is 648. Now, in 21st century that we live in, we don't need to pretend like there is no technology, so we can always check our work. And one of my favorite tools for simple tasks like this one is Desmos. All you have to do is type the function, and once you introduce the function, well, first of all, you get a nice looking graph of it that you can zoom in and play, but you can also do things like this. You can evaluate a function at any given number. You can also create table of inputs, outputs, which sometimes comes handy for certain tasks. So in this case, let me show you what it looks like. And here you can just plug in different values of x, and it will actually compute all the outputs and produce it in the form of this table. So looks like we got the answer, and we are 100% comfortable inputting this answer as the final answer. Similarly, we have what do we have here? We have a function, and this is actually the case where, well, let me write down the function. We can totally graph this function using Desmos, but what they're asking us is actually to graph it by plotting points. So here we're going to pick some values, and the easiest ones are 0 and 1. You can be creative and plug in values like -1 if you feel that way, and for each value we get to evaluate the function. Anything to the power 0 is 1, so the y-intercept of this function is 3/2. Anything raised to the power 1 is that value, the base itself. So the answer here is 3/4. Raising to the power -1, it's the same as reciprocating, so the answer is 3. So we can verify this by looking at the Desmos, and we can see here that let's just make this table a little shorter. We're getting exactly the same values as expected. So now when it's time for us to answer this question, we just need to pick 2 points, and it doesn't matter which we pick. So let's go with 0, 1.5, and 1, 0.75. So 0.75 will actually be below. So this is clearly a decreasing function because the base of the exponential expression is less than 1. And we got the right answer. Looks like we got another similar task, and I'm gonna be as efficient as I can be, assuming that we are allowed to do certain things like this. Of course, you see the Newton itself actually doing it by hand, if you can say that computer program does it by hand. Similar to what we've done before. So we have 7/2 times 4 to the power x, and at 0 it's 3.5, and at 1 it is 14. Now the next problem is actually taking us back to pre-algebra, and it is in pre-algebra we learned how to simplify expressions. And to simplify an exponential expression means to get rid of all the parentheses, to make sure that there are no negative powers, and to make sure that each base appears exactly once. So we're going to use, and I'm going to list the properties that we need right over here. So exponent can be distributed over multiplication and division. Also, when you have exponential expression as a base of another exponential expression, it can be simplified like this. We can combine bases this way, and we can also combine bases this way. And we also interpret the negative exponent as a reciprocal. So if I need more, I will add more to it, but let me just separate this. And let's get started. So first I'm going to use this property twice, and I'm going to distribute the power in the numerator and the denominator. Then I'm going to use this property 4 times, and I'm going to rewrite all those expressions that have parentheses and get rid of the parentheses. Next, I'm going to use this property, and I'm going to use it twice, one time for x and one time for y. So x is going to be to the power 4 minus -20, and y will be -2 minus -10. And now it's just arithmetic. So 4 minus -20 is 24. Y to the power -2 minus -10 is y to the power 8. So we simplified it. We have another one, so I'm going to use the same properties. Since we only have one variable, this one should be easier. But instead of the other variable, we have numbers. So let's see how it works out. First, we distribute the power of 4 over multiplication. And at some point, you'll learn how to cut the corners and not write every single step. But at the beginning of your journey, I would suggest you to write everything. Now here, I can just raise 2 to the power 4, but instead, I'm going to treat 2 as a constant base. And instead of 8, I'm going to write instead of 8, I'm actually going to write it as 2 cubed. So 2 cubed becomes 2 to the power 9. And here we have x to the power 12, and we have x to the power negative 3. So all together we have 2 to the power 4 minus 9 times x to the power 12 minus negative 3. A common mistake is students forget to put negative over here, and they just subtract 3 from 12, which is a mistake. We have 2 to the power negative 5 times x to the power 15. And we can leave it like this, or we can interpret as 2 to the negative 5 as 1 over 2 to the power 5, which is 32. We've seen this problem before, so let me utilize this template. 36, 3 to the power x over 2, and we're looking for f of 16, which is quite a big number, so you're probably going to use a calculator anyway. Might as well use Desmos. Very similar problem with a very similar solution. All right, moving on. Similar problem, right? So at this point, maybe we should start noticing some patterns. So when we have k to the power k times b to the power x, regardless of what k and b are, we should understand that the properties of all exponential functions are such that we pretty much know what the y-intercept is and the output of the function at 1. The y-intercept is always your coefficient k, so you see how I make k equals 3 and my y-intercept changes, and the output at 1 is always k times b. So if I make my base 2, then the output will be 6. So it's just a simple math. When you plug in 0, b to the power 0 becomes 1, so k times 1 is k. And when x is 1, b to the power 1 is b, so f of 1 is k times b. So when our b is 1/2 and k is 7/2, my y-intercept is 3.5, and my output at 1 is 1.75. And of course, it's a decreasing function because the base of the exponent is between 0 and 1. Similar problem. This time we can maybe try shortcuts here. So when x is 0, the output is just 3/2. When x is 1, the output is 15/2, which is 7.5. We have more exponential expressions, so Let's try this one. We have 2 to the power, or rather 2 times x to the power 2/3. So the only difference between this and the previous one is that now we have rational exponents, but how we use the rules hasn't changed because of that. So here we have 2 cubed x to the power 2/3 cube divided by 6 squared times x to the power -1/3 to the power 2. So we have 2 cubed, and instead of 6, I'm actually going to do this. I'm going to write, instead of 6, I'm going to write 2 times 3. And then instead of 2 times 3 to the power 2, I'm going to distribute the power 2 to 2 and 3. So here now we have this coefficient, and we have x squared in the numerator and x to the power -2/3 in the denominator. So the last step for us is to simplify. And now here we have a simple task of subtracting fractions. So it's the same as this. And now we're going to find the common denominator. So the final answer is 8/3 is the power of x. So 2 divided by 9, x to the power 8/3. Very similar problem. So I'm going to do it very similarly. Hopefully you can follow along. If you can't, please reach out. And this is the right answer, of course. So we finished the homework. If you have any questions about this homework or any of these concepts, please feel free to reach out.